Okay, last assignment. We're going to split it into 2 parts. Instead of doing 2 assignments, we'll just do a little bit smaller assignment, but with 2 parts. So here we want to talk about exponential functions. Okay, and the idea with this type of function is that our variable is in the exponent. Okay, so that's where we get the name exponential functions. And whatever this number is here, we're just calling it a here, just being general. Whatever this number is, we call this number our base. And we really only have 2 restrictions on our base. So we won't let our base be 0. So we'll say a is bigger than 0. And we also won't let our base be 1. So we'll say a is not equal to 1. And so those 2 things won't work. Any other number you can use for the base here. Okay, so like as an example, we could have a function g of x. And for our base, let's use 3. So we would have 3 to the x. Okay, so here our base is 3. And then our variable, whatever we're plugging in for x, is going to go in the exponent. Okay, so let's try a few values. Let's just evaluate this function for a few x values and get a feel for it. So let's make a little table. We'll write down what we plug in for x, and then we'll write down what we get out for g of x. Okay, so if we plug in 2, that means we'll have 3 to the second power, right? 2 goes where x is, and 3 squared is 9. So if we put in 2 for x, we get out 9. If we do 1 for x, then that'll just be 3 to the first power. Anything to the first power is itself, so we get 3. If we try 0 for x, then we'll get 3 to the 0th. And our rule is anything to the 0th power is 1. Okay. Let's try some negative values and see what happens. Okay, so we did 1. Let's try a negative 1. And then that'll be 3 to the negative 1 power. Remember, the way we can deal with a negative exponent is we move it to the other side of the fraction. So that's like 1 over 3 to the first power, which is just 1/3. If you do it in your calculator, you'll get a decimal. That's okay. If we try negative 2 for x, then we get 3 to the negative 2. So that's 1 over 3 to the second power, or 1/9. So you might be able to see a pattern here as our x values get bigger. All right, going this way. So our x values get bigger, our y values get bigger. Right. But if we go toward negative x values and we get smaller and smaller x values, what's happening? Our y values are also getting smaller, right? 1/9 is smaller than 1/3. Okay, so that gives us a general idea of what these graphs are going to look like. Just in general, if we have something like this, if we just have a f of x is a to the x power, well, what's that going to look like? We had this one example where we used a base of 3. Okay, sorry about that. Had this example where we used a base of 3, so we said in that case that, well, let's look at one special point. We got one special point, and that's when we have an x of 0. We get a y of 1. Okay, that turns out to be a special point for exponentials. So we'll go to 0, 1. Got that point on our graph. And we said as we move to the right, our y values get bigger, and as we move to the left, our y values get smaller. But notice one thing about our y values is they're not negative. They're getting smaller, but they don't go negative. So in general, our exponential function is going to look something like this. Okay? We're never going to get negative y values out of these things unless we have a minus sign in front. If we just have a positive base, we're never going to get a negative y value. So another way of saying that is down here at the y-axis, the x-axis. Okay, the x-axis is a horizontal asymptote. Okay, That means we're never going to cross that line. Never going to cross the x-axis with these. Okay. One thing that can change though, on this one, the one we looked at, we had a base of 3. Okay. So remember, we can't have a base of 0, we can't have a base of 1, but we can have numbers between 0 and 1. So that would be like if we had something like this. If we had maybe an exponential function like this, so we could have something between 0 and 1 raised to the x power. So if we think about the graph on this one, what's going to change? We're still going to have a special point on here, okay, because if you raise 1/2 to the 0th power, we still get 1, so we get this 0, 1 point on here. That's going to be on the graph of all exponential functions unless they've been shifted. But what changes here is that instead of getting our y values getting bigger when we go to the right and smaller when we go to the left, it's flipped. Okay, so we're going to have a reverse image here. Okay. But still, again, the x-axis is a horizontal asymptote here. Okay. So it's still never going to cross the x-axis. All right, so let's look at some transformations we can do with these. We've talked about transformations of functions like shifting them left and right, up and down, and doing reflections. So what do those translations look like? Transformations look like with these things? Okay, well, let's think about this function. F of x equals 2 to the x plus 1. Okay. Well, if we do that, just like with our other functions, we've just got this plus 1 tacked on to the end. That means we're just going to take our graph and we're going to shift it up 1 unit. Okay. If it was negative, we would shift it down however many units. Okay, so hopefully that's pretty familiar. Let's look at another one. Okay, if we have something like this, have f of x equals 2 to the x plus 1 in the exponent. So now the plus 1 is up in the exponent. So if you have a plus a number or minus a number up in the exponent, what's that going to do? Well, remember we said with our other transformations, if it's inside the function with the x, then that's going to be a horizontal translation. So in this case, it's plus 1 up here with the x. Remember, these are kind of backwards, so plus 1 means we're going to go left 1 unit. Okay. If it was a minus 1, we would go right 1 unit. If it was a minus 7, we would go right 7 units. Okay. There's one other big one we want to know about with these. This one like this. We said we don't let our base be negative, but what if we just throw a negative out in front? Okay, so we have negative 2 to the x. Okay, or another way you could write this, maybe to make it more clear, is if we have negative 2 to the x. Those two mean the same thing. Well, what happens then, if we remember from before, if we just put a minus sign out front, this negative is going to be a reflection. Which kind of reflection? It's going to take everything that had a positive y and change it to a negative y, so this is an x-axis reflection. Okay. One other big, really important thing with exponential functions is you can use any number for any positive number for a base that's not 0 or 1. Right? We've seen some of those examples. So there's one special base that you'll see sometimes, okay? And that would be in a function that looks something like this. Okay, we would have something like f of x equals e to the x. Okay? And all e is just a number. Okay, it's a special number, so we give it its own symbol. Kind of like with pi, right? We can write the symbol pi instead of writing 3.14 blah 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 forever and ever. E is an irrational number like that also, so it goes forever and ever. But we take the first few digits, right? Pi is 3.14, on and on and on. E is about 2.6 7182818, and goes on and on forever. So sometimes we shorten it and say pi is approximately equal to 3.14. Well, we can say E is approximately equal to 2.72. Okay, so if you see E involved, that's just a number. You'll have a button on your calculator that will give you E. So if you need to evaluate anything with E in there, just use that E button on your calculator, but don't let it intimidate you. It's just a number.